Hey everybody, welcome to our video lesson on scatter plots. Now you guys have talked about scatter plots in the past, so we're going to take all of the knowledge that you know from middle school and we're going to expand it and we're going to try to explain some of the ways that we can use scatter plots to make inferences and predictions and what kind of information we can use once we see them. All right, so the first thing that I want to explain is that you're going to use a scatter plot if you're displaying what's known as quantitative bivariate data. Now we've talked about the word quantitative before. It looks a lot like the word quantity. That's because we're going to be using data that is either numerical or that has a measurement to it. So we're going to stick in that numerical framework when we talk about the data that we're working with today. But now instead of univariate, which is what we've been dealing with in the past few lessons, we're going to talk about bivariate. Now some of you guys might already be able to guess what that means, but bivariate means that you're measuring two variables at once. With that prefix bi meaning two, we're now going to be sort of comparing two different measurements all in the same question. All right, so I have an example right away of a scatter plot that's already done, okay, and this is measuring the heights of students and their test scores. So those are my two different variables. Obviously, test scores can be very different, and so can someone's height. So they're varying in both cases. And each one of these little dots, if you can see them, I probably should have made them a little bolder, represents a single person whose data was collected for this example. Okay, this person had this test score and this height, and this person all the way up here had this height and this test score, and we would be able to find the two variables for each dot. I just went in and made those dots a little bit darker because I could see that they were not coming up well on camera. Now, in your notebook, when you're writing along with me, these dots are completely random. Don't try to recreate exactly the scatter plot that I have. You can go ahead and fill your scatter plot with dots of your choosing, but the important thing to recognize here is these dots are all over the place. There's no sort of pattern to them. They're not in any sort of order. They don't seem to be leaning towards one side or the other. And there seems to be almost no relationship between test scores and height. And that should make sense. No one's height determines their test score, and no one grows based on what score they got on a math test. These two variables have no relationship to one another, and that's why that scatter plot seems so super dispersed. Instead of using the word relationship in statistics, we use the words correlation. All right, they roughly mean about the same thing, but correlation is a mathematical statistical term. All right, now what you want to see with the scatter plot is you want to hopefully see some sort of relationship that can help you make inferences about data that you don't have, maybe data that's happening in the future or data that expands your data set to other people that weren't included. So the two other possibilities when you look at a scatter plot, besides no correlation, is they could have a positive correlation or they could have a negative correlation. Okay, now I like to describe this as positive being moving in a general upward trend, just like the positive slope of a line would force our line to be moving up and to the right. And a negative correlation would be something moving in a general downward trend, just like the negative negative slope of a line would have us going down and to the right. So if I have a positive correlation, I would expect as one variable increases value, so does the other variable. And if I had a negative correlation, I would expect one variable's increase while the other variable decreases. But either way, having a positive correlation or a negative correlation would help me make predictions, which is the ultimate goal of statistical collection. All right, so what I'm going to show you guys today is how to generate a scatter plot on your calculator. I know you guys have experience doing it by hand with a very small data set, but we're going to be working with larger data sets in high school with some higher numbers, and instead of building them by hand when our goal is to go pass the data and make our predictions or inferences, we want a quick look at that display as fast as possible. So I have a data set that I collected where I measured the number of hours that was spent studying and the corresponding Regents score for that student. So take a second, pause the video, copy down this table so that you have it in your notebook, and then make sure you have your calculator with you, because that's how we're going to generate our scatter plot. All right, so what I'm going to do here is I'm going to have a similar first step to what we did when we were putting other statistical values into our calculator. I'm going to tell the calculator what the data is and give it all the information that it needs. So now that we have two variables, we're actually going to use two lists. If the table or the data set gives you an X value and a Y value, X should go in L1, Y should go in L2. If it doesn't, then try to decipher which one is your independent variable. That should always be represented by X, and that's going to go in our L1. And in this case, that would be hours studying, and then our Regents score is going to be L2. So what you guys are going to do is you're going to hit the stat button, and then you're going to choose the edit option. Okay, I already punched in my numbers so that I had them ahead of time, but in list 1 you're going to go ahead and put in all of the numbers of hours studying. So there should be a total of 13, I believe. Yep, 13 values. And then once you've put in all the hours studying, you're going to go over to the right so that you're in list 2. And then you're going to enter all the Regents scores that are in this table. All right, it is very important to make sure that the order is put in the same way for both rows in this case. What you want to make sure is that your hours studying and Regents scores that are matched up here are also matched up here. So this is not one of those cases where I can just plug in the numbers however I want. They are paired together in a specific way, and I want to make sure I carry that over to my calculator. All right, but once my calculator has my information, it is able to generate a scatter plot. So what we're going to do is we're going to go to y equals, and this is the shortcut version. I'm going to go up to where it says plot 1. Normally my cursor's in Y1. Make sure you clear out anything that's in your Y equals rows. If always scan down even further, because sometimes if there's a random button, your calculator is going to get confused. But I'm going to hit up to where it says plot 1. It's blinking right now. I'm going to hit enter, and you'll notice if I come back down, there's now a box around that word plot 1. That means that my plot 1 is turned on. Okay, that's the shortcut. If you want to change more things about it, you can always go to second and then y equals, which is stat plot, and go into the first option. All right, this is going to allow you to turn it on and off. It's going to ask what type you want, so you can make box and whisker plots, you can make histograms in here, pretty cool. And then you do want to make sure that your X list is L1, your Y list is L2, but as long as you guys haven't been using your calculator for statistics in the past, that should already be done for you. You can also choose what kind of marks. This is like a little outline box. Then you've got a plus sign or a dot. I recommend just leaving it on that outlined box so that you can see it the best on your calculator. All right, but in general, we just go to y equals. We make sure that plot 1 is on. If you're not doing statistical stuff, then you want to make sure that plot is off, because now if I try to plug in y equals mx plus b and graph a line, my calculator is going to be trying to read the statistical information that I input. So right now it's on because that's what I'm going to be using, and I'm going to go to the zoom button, middle top, and I want to go to option choice 9. Okay, zoom stat is the calculator's way of generating a window that goes exactly to the data values that you plugged in. So you can either hit zoom and then just the number 9, or you can scroll down to 9, hit enter, and boom, there is my scatter plot for our Regents exams. All right, and I wrote down the steps down here at the bottom of the page, so if you need to pause the video and copy them down into your notebook so that you have them, I definitely recommend that for future reference. But now that I can visually see my scatter plot, I can tell that there is a slight positive correlation. They're not super tight together like my example here. They're a little bit more spread out, but they do move in that general upward trend. So I would say that there is a positive correlation between our studying and Regents scores, which means in general, as the number of hours increases that you study, so does your Regents score, again, in general, not directly affected. We'll get to that in a second. All right, so as you guys know, it's not really like mathematicians to be very vague and general and talk about this scatter plot and say, well, there kind of sort of seems to be a general positive relationship between these two variables. We always want to be exact, and we always want to have a measurement. We want to have a numerical value, and that's where the correlation coefficient comes into. All right, so we could have a positive correlation, a negative correlation, or no correlation at all, but we do have a numerical value to represent how strong that relationship of the two variables are, or what kind of correlation they have. Now, your correlation coefficient is always going to be in between -1 and +1. It can be -1 or +1, but that's very rare. All right, and if it's at -1, it's a very strong negative relationship. Those dots in my scatter plot would have been in a complete straight line, but moving in a downward trend. Okay, as we move closer to a 0, I might not describe it as strong. I might describe it as a moderate. That's if it's somewhere like -0.7. As we get closer and closer to 0, my relationship's going to be weaker and weaker until I get to 0, which would be more like that first example we saw where there was no relationship whatsoever. Okay, and then the mirror effect happens on the other side. As it gets higher than 0, my relationship can be described as weak. As it gets closer and closer to +1, it would be considered moderate, which is what I would consider this to be. I'm expecting maybe somewhere around like 0.6, 0.7 for this relationship here, because if it was truly a strong positive relationship, these dots would all form an exact straight line. Okay, now finding that correlation coefficient goes hand in hand with creating a line of best fit, which I believe you guys have done in middle school, and you may have done some estimates where you pick out two values, you connect the line, and then you generate your line of best fit. Again, in high school, we're trying to expand your knowledge, and we're trying to use your skills in statistics to go further and make predictions and make inferences. So I'm going to show you guys how to find that exact correlation coefficient, going straight off of the data that our calculator already has. All right, so we already went in, we put L1 was the number of hours studying, L2 was the grade that we got on a Regents. So I'm going to go ahead and go to Stat, and I'm going to go over to Calc, but now I'm going to scroll down to option choice 4, which says Lin Reg. Okay, now that word actually does mean something, and we're going to get into what that means and how we use it in a lesson or two. But for now, if we hit enter, okay, again, we want to see X list is L1, Y list is L2. We already had those set up when we did our plot. I'm just going to clear out the frequency list because I'm not dealing with a frequency table. I'm dealing with bivariate data. So clear that out. Everything else should be cleared, and then I'm going to go to calculate. Okay. Oh, it looks like my calculator does not have the correlation coefficient. What I'm looking for is an R equals statement under here. Okay, so this is a perfect way to segue into how to turn your stat diagnostics on. Okay, so if we don't have our statistical diagnostics on, this is all we're going to see. We're going to see A equals, B equals, and for right now, those should not make any sense to you guys just yet. All right, but I'm going to turn my stat diagnostics on, and you might want to do this if your screen looks like mine. It won't hurt if it doesn't look like mine and you do it anyway. But I'm going to go to mode, which is right next to the second button, and I'm going to scroll down to the second page, and 1, 2, 3, about the 5th line, it says stat diagnostics. I want to go over to on, hit enter, make sure it's bold or highlighted, however you see that, and then I'm going to repeat that process that we just used to find the correlation coefficient. So I'm going to go to Stat, Calc, Lin Reg. Everything should already be the same way I just had it, so I'm going to keep hitting enter until I get to calculate. And then you'll notice there are two new variables that pop up. Okay, the correlation coefficient is going to be the R value. So I'm looking for R equals, okay, and that's going to tell me my correlation coefficient. In this case, I have a correlation coefficient of 0.817, so something that's relatively close to a 1. It tells me that I have a positive correlation, which I already knew from looking at the scatter plot, and I have a moderately strong correlation because it's so close to 1. They're not all squished together and forming that straight line. That's what a R value of 1 would do, but they're pretty close. They're relatively close together, and this is the measurement I would use. Normally, they tell you to round it to the nearest tenth or hundredth, but the important thing is to recognize that the closer it is to positive 1, the stronger that relationship is between those two variables. So now that we're on the topic of the strength of a relationship, it's important to know that two variables can be very strongly correlated with one another, but they don't necessarily have a direct effect on one another. And the last thing that we're going to cover in today's lesson is correlation versus causation. So a correlation is a relationship between two variables. It could be positive, it could be negative, it could have no correlation. And then a causation deals with what we call a causal relationship. 99% of freshmen are going to either misspell this or mispronounce this. It's not casual. It's causal. So switch that U and that S. So a causal relationship is where a change in one variable directly causes a change in the other. So they're going to have such a strong relationship to one another that they're actually going to be considered like a cause and effect type of relationship. So I have 4 examples here in my notebook of variables, bivariate data that might be measured in the same data set. And I'm just curious if you guys can recognize whether or not it is causal. Okay, so take a second, pause the video, and look at each one of these 4 examples. Does one variable directly change the other variable that's being measured? What do you think? All right, let's start with number 1. Height of a student and overall GPA. Now, I don't know about you guys, but when I grew inches in high school, I did not automatically get higher scores in my classes. And the vice versa, unfortunately, didn't work either. If I got a really good test score, that did not mean that my height changed. So I wouldn't even say that these two are related at all, but I would definitely say that they are not in a causal relationship. One is not going to change another. All right, number 2, number of hours worked and the amount paid at a summer job. Now, I included the word summer job because we're thinking like part-time jobs or jobs where you're paid hourly. Things that you're paid on a yearly salary, the time that you put in on a daily basis is not necessarily going to change your salary. But if anyone's ever had a part-time job or a summer job, you know that if you work more hours, you get paid more, and it is an actual cause and effect relationship. If I work an extra hour, I get paid an extra X amount. So this is causal. Okay. Number 3, does the temperature outside cause people to study more or less? Or does the number of hours you study cause the temperature to change outside? Now, I know there's a pretty strong negative correlation between these two because as the temperature rises outside, people are less likely to spend their time inside studying. Oops, sorry, I was a little fuzzy there. So I know there's a negative correlation, but there isn't that direct causation. If the temperature increases by 5 degrees, you're not automatically going to stay outside and study less. So this is not a causal relationship. It might be a strong relationship, but it's not causal. And the last one that I have as an example, miles driven and the amount of gas in your car. Okay, so you guys might not be driving directly, but you should know from maybe long road trips with your family, the further you drive, the less gas that's left in your car. The more your car uses, so the less it has. So every extra mile you drive causes the amount of gas in your car to decrease. So yes, this would be considered a causal relationship. Okay, not only a very strong negative relationship in terms of correlation, but we can actually go one step further and say that it is in the causal realm. All right, so that's all the stuff that we're going to cover on scatter plots and bivariate data introductions. If you have any questions, please reach out to me. Otherwise, check out for the practice assessment and make sure you have everything submitted to Google Classroom. Have a great day, everyone.